Hello everyone. In today's video, I'm going to show you how to calculate arc lengths of a given curve in a given interval by solving two sample problems. Let's get started. The first question is find the arc lengths of a given curve in a given interval, and then the curve is y is equal to 1 plus x to the power of 3 over 2 from 0 to 1, or 0 is less or equal to x, x is less or equal to 1. So in this problem, I have the function or the curve, and then I will find the arc length of the arc length from that curve from this interval 0 to 1. Okay. So as always, what we have to do is we have to remember the formula to calculate the arc length. So the arc length formula was given by this one. L is equal to the integral a to b square root of 1 plus f derivative of f derivative square times dx. Okay, this is very important formula. So obviously you know that f derivative means just simply dy by dx. Okay, this is dy by dx. Okay, so this is dy by dx. I hope everybody knows this one. It's the same thing, all right. Now the first thing is look at the one inside the radical. Okay, 1 plus f derivative square. So to plug in something inside this square root, let me finish my f derivative. So that means if f of x is equal to the given function, which is 1 plus x to the power of 3 over 2, right? So the derivative of that, okay, the derivative of that is the following. You know the rule of derivative, and this will tell me that the derivative of the constant number is 0, and then the derivative of x to the power of 3 over 2 is, I bring 3 over 2 to the front, right? And then x 3 over 2 minus 1, I subtract 1 from 3 over 2, so I remain with 1 over 2, right? The power of 1 over 2. So I can further rewrite this as follows. Okay, this is the same as 3 over 2 x to the power of 1 over 2 means square root of x. Okay, so this is my derivative, f derivative, or when I just use the derivative of f of x, I'll get this answer. Now let me go to the original equation. Okay, my original equation is L equals to, right? Now I know my limit of integral from 0 to 1, okay, because that's the interval from 0 to 1, and then square root of 1 plus, what is f derivative? F derivative is this guy in here, that is 3 over 2 under square root x. Okay, since I have this square, I have to square this one. Okay, I have to square this one, I have to square this one, times the dx. Okay, times the dx. Now observe L equal to 0 to 1. All right, still square root of 1 plus, right? So what will this square, or this the power of 2, do to the numbers and variable inside the parentheses? Okay, inside the parentheses. So this 2 is for everybody inside the parentheses, and then that will make the 3 9, right? That will make the 3 9, and then that will make the 2 4, because 3 square is 9 and then 2 square is 4, and then that will make x for the square root of x, because you remember that square root of x, the whole square is equal to just x, right? So this is what happened. So, and then this is of course dx, right? So the next step is going to be this. Now, how can I solve this one is the question now. So I can use now u substitution. Okay, I can use u substitution at this point. Okay, substitution, all right, u substitution. So according to u substitution, let my u is gonna be the one inside the parenthesis, which is in the square root, which is 1 plus 9 over 4 x, right? This is my u. And then my du, or the derivative of u, is gonna be the derivative of the first number constant is 0, and then the derivative of 9 over 4x is going to be simply 9 over 4 dx, okay, 9 over 4 dx, because the exponent of x is 1, 1 minus 1 is 0, x the power of 0 is just 1, so I remain with 9 over 4. Okay, now from this I can rearrange for dx. Okay, I can rearrange for dx. So my dx is gonna be 4 over 9 du, right? I reciprocate this. Now let's go back and then insert all the necessary ingredients from here. So that's gonna be from 0 to 1, square root of, right? Square root of uh, u, just u. Now I'm gonna insert u because my u is 1 plus 9 over 4x, which is the one inside this. So times the du is going to be now 4 over 9 du. All right, so everything is written now in terms of u. I am now in the u world. Okay, great. Now the next step is here. I can do something. All right, so remember u is 1 plus 9 over 4 x. Okay, so I can change now my limit of integral here. Okay, I can change now my limit of integral here. So that means that if I plug in x is equal to 0, then u is equal to 1 plus 9 over 4 times 0. Okay, times 0. So this is u is equal to 1 when x is equal to 0. All right. And then the second one is when x is equal to 1. So that means 1 plus 9 over 4 times 1 is equal to, this is 9 over 4. 1 plus 9 over 4 is actually 13 over 4 when x is equal to 1. Okay, so now I have two new limits. Okay, I have two new limits. The two limits are the following. So this is the 13 over 4 and the 1. Okay, 13 over 4 and the 1. So I can write this one again like this. Okay, 0. Now I have to change my limit of integration because I already have a new limit by substituting x. So my new limit is going to be this one. My new limit is going to be this one. From 1, all right, this 1 to 13 over 4 square root of u, and then times 4 over 9 du, all right? 4 over 9 du. This is the new one. Okay, now after that, this is getting quite simple. So I can take out the 4 over 9 outside. 4 over 9 into 1 to 13 over 4, right? This is u, the power of 1 over 2 du, right? Du. Nice. So this is going to be like this one, all right? So still 4 over 9 is outside, right? 4 over 9 is outside, times u the power of half. The integral of u the power of half is going to be, you have to add 1 plus 1 over 2 is equal to 3 over 2, and then you divide to that 3 over 2. So this is going to be u the power of 3 over 2, right? 3 over 2 into 3 over 2, right? This is from 1 to 13 over 4, right? So this is something I have to understand. So the next one is L, this is L, then this is going to be, let me rearrange this. L is equal to 4 over 9, 4 over 9, this is equal to, L is equal to 4 over 9, times, right? Let me rearrange this, 2/3 of u the power of 3 over 2 from 1 to 13 over 4. Okay. Okay, now almost close to the end. So this is going to be L is equal to, what is 4 times 2? Because I can take out the 2 over 3 again out of, already it is out of the integral, but I can just multiply it with this one. I can multiply it with this one. That's going to be 8 over 27 times u the power of 3 over 2, that runs from 1 to 13 over 4. Okay, that's the limit of integral. So finally, I'm about to finish. So L is equal to 8 over 27, right? Times, okay, this is gonna be U. Instead of U, now I can substitute my numbers, my limits. At this point, I can substitute my limit of integration. So that's gonna be from upper limit to lower limit, which is 13 over 4, the power of 3 over 2, right? 3 over 2, subtract 1, the power of 3 over 2. All right. So from this, just I will leave it for you just to use your calculator or any method to calculate this number. So finally, this answer is just simply a number. I just leave this one for you to find out what is the exact number. Okay, what is the exact number? All right, let's proceed to question number 2. Question number 2. Question number 2 is as follows. Okay, this is number 2. All right, question number 2. Still, we are doing the same problem, finding the arc length of a given curve. We're gonna follow the same formula, the same procedure, but maybe different question. Okay, different question. All right. Y is equal to 2x minus 5 between -1 and +3. Okay, so this is my curve. So as always, the integral from a to b of 1 plus f derivative square of dx. All right, so let's go. F of x is equal to the original function, which is 2x minus 5, and then f derivative of x is equal to, or the derivative of x is equal to just 2, because the derivative of this is 0, and then the derivative of 2x is just 2, because I have 1 here. 1 times 2 is 2, 2, 1 minus 1 is 0. So x to the power of 0 is just 1. Then finally, I will have 2. All right. Now, the next step is go ahead and plug in into the original equation, everything. Okay. So my limit is from -1 to 3, right? Under square root 1 plus the derivative of this is 2 square, right? 2 square dx, right? I plug in the 2, everything is in place now. Now this is going to be the following, right? -1 to 3 square root of 5 and dx, right? So this can be further simplified as follows. Root 5 is a constant. I can bring it outside of the integral. So this is root 5 times the integral of dx from -1 to 3, right? And then this will take me to this. What is the integral of dx? The integral of dx is just x. So square root of 5 times x from -1 to 3, from lower limit to upper limit. So this is finally root 5 times, so the upper limit is 3 minus the lower limit is -1, -1, all right? So this is finally root 5 times 4. So this is equal to 4 root 5. So 4 root 5 is the length of the arc, okay? Length of the arc. So I hope you enjoyed the video, and I will see you in another video next time. Have a great time. Bye bye.